Hi dear students, I hope you all are doing great. Now this particular video is related to your board level questions, some extra questions on chapter light. Previous video was being uploaded for chapter light which was related to NCERT questions. This is from grade 10 Cbse. Let's take question number 1. In order to obtain large images of the teeth of patients, the dentist holds the concave mirror such that the teeth are positioned. The options are given at the focus, between pole and focus, between focus and center of curvature, and at the center of curvature. Students, before you solve these questions, it's a request that you go through the previous video, part 1, where you will understand about the different terms which are related to the ray diagrams. So a concave mirror, it gives a magnified plus virtual image. That means when object is between pole and focus. So what will be our answer? Answer is B, that is between pole and focus. So this you have to remember. Question number 2. Could you see some ray diagrams on the screen? This is all the important questions which are shared for the related to the practice for the ray diagram. So you need to identify from the following ray diagram which shows the correct path of the reflected ray for the ray incident on a concave mirror as it is shown. So you find here there are A part which tells us about the ray which is reflected but it is not passing through the focus. The other ray, which in B part, it is reflected but at the center of curvature. For the C, it is passing through the focal length, and likewise if you see in D1 it is deviated, it is not passing, it is reflecting back. So what will be the options? You can pause the video and understand the what will be the right option. Let's understand what is the next or the right option. So let's understand the solution for this. So you need to identify the ray diagram which shows the correct path of the reflected ray. So the C is the right option. That is, a ray parallel to the principal axis always reflects through the focus. So please remember this. Let's understand the next question. Now you name the type of mirrors. Now this is just a mixed bag type of question which I wanted to share with you all. Now type of mirrors. Now, if suppose we understand the magnified and the virtual image, it is produced by which mirror? That is concave mirror. And where will be the object position? It is between pole and focus. Now, when we talk about diminished and virtual image, it is produced by which mirror? That is convex mirror. And image is always virtual, erect, and diminished. So you need to remember this when we are talking about magnified and virtual image. That means it is produced by concave mirror, object is between pole and focus. And if it is diminished and virtual image, so object is produced by convex mirror and it is always virtual, erect, and diminished. Question number 4. So which mirror gives magnified real image? That is concave mirror. And what is the condition? That is object is between focus and center of curvature. And what will be the formation of image? It will be real, it will be inverted, magnified. Let's understand question number 5. Now if you see the question on the screen, students, hold a concave mirror in your hand and direct its reflecting surface towards the sun. Direct the light reflected by the mirror onto a white cardboard held close to the mirror. Move the cardboard back and forth gradually until you find a bright, sharp spot of light on the board. This spot of light is the image of the sun on the sheet of paper, which is termed as principal focus of the concave mirror. This is some explanation or introduction being given, and you see the diagram on the screen. Now in this question, we have tried to solve the ray diagram to show the type of image formed when an object is placed between the pole and focus of a concave mirror. Rest A and B, you can pause the video and try the questions, and in the further video you will find the explanation of these type of questions are done or explained to the students. So first thing, place the object between pole P and focus of the concave mirror. So you have to draw two rays. One is parallel to the principal axis, which reflects through the focus. One towards the pole, which is reflecting or reflects obeying the law of reflection. Now I'm very sure that everybody knows what is law of reflection. The reflected rays will diverge, so you extend them backward. They meet behind the mirror, forming the image. And how is image formed? Virtual, erect, and magnified. So I'll be showing you the graph so that you understand the points which we have mentioned here. That will help you to know that where the image is formed. Where the image is formed? Behind the mirror. So you can see this. This is the image which is formed. Position of the object is between pole and focus, and then position of the image, it is behind the mirror. So what are the properties of the image here? It is enlarged, it is virtual and erect. I hope this question is clear. It is extremely important related to the board exams. Question number 6. How is there a relationship between the power and the focal length? There are two lenses with focal length of 20 cm and 40 cm respectively. Which of the following lenses will form more convergent light? Now the lens power is what? It is the reciprocal of the focal length. Please remember this when we are talking about power. It is reciprocal of what? Reciprocal of focal length. So here whatever is mentioned, we'll write it down. For power, that is 1 focal length, and we have converted into 100 focal length in meter. Likewise 20, so it is 100 upon 20, that will give you 5D, that is 5 diopter. So then it is 20, so sorry, it's 40, so it will be 100 upon 40, which is 2.5 diopter. So they will be more convergent in the lens with a focal length of 20 centimeter. So when we are talking about the focal length here, 20 centimeter, there's a 20 centimeter focal length and it's 40. So where will be more convergence in the lens? That will be in the focal length of 20 centimeter. Question number 7. The linear magnification produced by a spherical mirror is +3. Now this is the magnification given. Analyze this value and state the type of mirror and position of the object with respect to the pole of the mirror. Draw a ray diagram to show the formation of image in this case. Now positive value of the magnification. What does that indicate? That indicates that image is virtual and erect. Since the image is magnified, so the mirror is concave. The object is between pole and focus of the mirror, as you can see of the graph. So now again you need to remember that object is between pole and focus of the mirror as there is on the graph. You can pause the video and even you can draw the diagram and the points given there. Next is question number 8. A concave mirror has a focal length of 20 centimeter. At what distance from the mirror should a 4 centimeter tall object be placed so that it forms an image at a distance of 30 centimeter from the mirror? Also calculate the size of the image formed. Now you have to use sign convention for a concave mirror. Focal length is minus 20 centimeter. V, that is your image distance, it's minus 30 centimeter, that is real image forms in front. Students, again, before you go further and solve the question, it's a humble request that you please learn the sign convention and go through the video which has been uploaded and understand, write down all the notes, and then these numericals will be easy for you. So you need to substitute the value in the equation. So once you substitute the value, you will get U as minus 60 centimeter when you are calculating it. So this is your answer. And where the object should be placed? Between 60 centimeter in front of the mirror. Let's see question number 9. The image of an object formed by a mirror is real, inverted, and is of magnification -1. This time the magnification given is -1. If the image is at a distance of 40 centimeter from the mirror, where is the object placed? Where would the image be if the object is moved 20 centimeter towards the mirror? State reason and also draw a ray diagram for the new position of the object to justify your answer. So I'll quickly explain you with the graph and the steps what you have to use. Now see this. For a mirror, an image that is real, inverted and of magnification -1 is formed when the object is at the center of curvature. In this case, the image is formed at C itself. So all the rules and steps you need to understand where the image is formed. So image is at a distance of 40 centimeter from the mirror, which is given, which is center of curvature is at 40 centimeter. Hope this point is clear to you. Now the position of the object is placed at the center of curvature, that is 40 centimeter in front of the mirror. Hope this point is clear. Now when the object is moved 20 centimeter towards the mirror, okay, if you look at the diagram you will understand, object is moved towards the mirror, so the new position of the object will be 40 minus 20, which is 20 centimeter. So the object is now where? It is at focal point. Now because F is at the half of the distance of C, that is, it is 20 centimeter from the mirror. If you can see this one, 20 centimeter from the mirror. So the new position of the image, when the object is at the focal length of a concave mirror, the reflected rays are parallel to the principal axis and the image is formed where? At the infinity. So we can see these parallel lines, red, blue and purple, which is emerging that they never meet at any finite distance. That means the image is at infinity. Hope these steps and the points and the diagrams are clear. You pause the video and request if you draw the diagrams and redo these questions again. Question number 9. The image of an object formed by a mirror is real, inverted and is of magnification -1. If the image is at a distance of 40 centimeter from the mirror, where is the object placed? Where would the image be if the object is moved 20 centimeter towards the mirror? State reason and also draw a ray diagram for the new position of the object to justify your answer. Now, what is the first step, students? Identify the mirror and given data. So image is what? Real and inverted. So you don't have to worry, it's given. And it is only possible when? With the concave mirror, which I have taken in the previous questions. What is the magnification given? -1. Again, children, I am repeating this on and on, that please write what is given in the question. That will help you to answer it well, step by step. Now, mirror magnification formula, that is m is equal to -v upon u. So what is given? M is -1. So if m is -1, now minus v upon u. So what you have to do here? Here we have just cross multiplied. Minus sign is cancelled and we have got v is equal to u. So object distance here is equal to image distance. Hope this point is clear to you. So given image distance, now can we go further? If the image is at a distance of 40 centimeter from the mirror. Now why it is negative? Because real image, it forms in front of the mirror. Therefore, we will get u as -40 centimeter. Now let's find the focal length. For that, which formula you have to use? Mirror formula. So 1 upon f is equal to 1 upon v plus 1 upon u. Students, you just have to substitute following the sign convention. You will get focal length as -20 centimeter. So now move object 20 centimeter towards the mirror. So what will be the new position now? It is -40 plus 20, that is -20 centimeter. Now object is now at the focus. So this point is clear. Now step number 4. Now we need to find the new position. See children, we have given the reason. We need to find the new position of the object. So again, using the mirror formula, substituting the value of focal length of V and U, V we have to find, and then you will get V is equal to 0, 1 upon V is 0, that means V is infinity. Hope this point and these steps are clear to you. So further continuation of the previous question, this is the ray diagram. So once you have solved all the questions with the steps, request that you draw the ray diagram also. Question number 10. This is the last question. Calculate the magnification of the image of an object placed perpendicular to the principal axis of a concave mirror of a focal length 15 centimeter. The object is at a distance of 20 centimeter from the mirror. Now, what is the focal length of a concave mirror? It is minus 15 centimeter. What is the object distance? Minus 20 centimeter. Again, students, very important, sign convention. So distances measured towards mirror are negative. So using the mirror formula, 1 upon f is equal to 1 upon v plus 1 upon u. Substitute the values, and once you will calculate, taking an LCM, you can use any alternative method to solve it, as it is the little bit maths required here, where you need to calculate it, but see to it that you work on these calculations as well. So you get V as minus 60 centimeter. Now next part is you need to calculate the magnification. That is the next step. So what is the formula? M is equal to minus V upon U. So M, when you just substitute the values, you will get M negative 3. Thanks a lot for watching. More exciting, informative videos are coming soon. So we are going to cover different chapters of physics, chemistry, and mathematics. Students, don't forget to like, share, and subscribe, and to stay updated. Thanks for all your support. And also, very important thing, the next video will be on chapter electricity, conceptual learning, concept-based questions, and detailed explanation for your better understanding. So stay tuned. Thank you so much. God bless you. Have a wonderful time.